And here is our last topic of the year. Super exciting and also super easy. So looking at acid deposition, which is these pollutants that are react with water in the atmosphere, so that water vapor in the atmosphere, leading to some acid formation. And then that acid is deposited on Earth's surface. So we're very concerned about nitrogen oxides and sulfur oxides leading to this acid rain. Carbon dioxide is a problem if we have too much carbon dioxide. But carbon dioxide in fairly normal amounts actually leads to a fairly normal acid-ish rain with a pH of about 5.6. This is what we have most of the time. This is considered normal. So normal amounts of CO2 lead to a normal acidic pH of about 5 or 6 when it comes to precipitation. Precipitation being rain, hail, snow, lots of stuff. What happens is the CO2 and the water react in the atmosphere. We get that carbonic acid, which can donate a proton, leading to that hydrogen carbonate polyatomic ion, that proton causing the rain to be slightly acidic. pH 5.6, pretty normal. What's less normal and therefore more concerning is the acid rain caused by nitrogen oxides and sulfur oxides. So here we have some examples of equations related to acid rain formation. So sulfur dioxide here, dinitrogen monoxide here. These guys can react with oxygen in the atmosphere, leading to some sulfuric acid here. We've got some nitric acid here. These guys then react, dissolve. They dissolve in water in the atmosphere. And then the rain has those hydrogen protons that are characteristic of acids. This is what leads to pond life dying because of a too low pH, highly acidic water environment. This is also what leads to the corrosion of marble statues and outdoor gardens. So this is the acid rain that we are concerned about. So again, CO2 here, again, in normal amounts, leads to that normal pH of 5 or 6. Sulfur oxides, nitrogen oxides, these guys, sulfur with oxygen, nitrogen with oxygen, are going to react with oxygen in the environment, in the atmosphere, and lead to some acids that then cause acid rain, which is problematic. We have some things that we can do in order to reduce somewhat the acidity of these pollutants. The first thing that we can do is actually clean the fuel, the fossil fuels, prior to burning it. What we do here, this is actually how we make clean coal. So we smash up the coal, we crush it, and then we float it through some water. When it's floating through the water, some of those impurities, the sulfur and the nitrogen, can settle out of the crushed pieces of coal. That coal ends up at the end of the wash cycle, and it's clean in terms of not having those impurities. Less sulfur is released to the atmosphere, less nitrogen is released to the atmosphere, but we still are pumping out a lot of CO2. So clean coal still releases huge amounts of CO2 into the atmosphere, just a little bit less of the nitrogen oxides and the sulfur oxides. Also, this water has to be disposed of, usually in the ground, which means that rather than have those sulfur and nitrogen oxides floating around in the atmosphere, we now have them floating around in our water supply. May not entirely be better. Another option that we have for reducing acid rain is by adding filters or scrubbers to the smokestacks of our factories, to the exhaust pipes of our cars. And the goal is releasing less of those contaminants into the atmosphere. These can work pretty well. They are expensive. And so some companies, some car makers prefer not to have to install them. And then also at the end of their lives, when these filters are quite dirty, need to be replaced, we throw away the filters. And so again, this stuff may not be released into the atmosphere, but is now in the ground and in the rain, dissolved in our groundwater. So maybe different, but not entirely better. And that, my friends, is the end of what we need to know about acid deposition. I'm so proud of all your work this year.